In this video, I'll go over inverse trig functions. Now's a good time to review your inverse trig knowledge from pre-calculus. Let's look at one for an example. Inverse sine. Y equals inverse sine x means sine y equals x, where x is a value between -1 and 1, and y is a value between -π/2 and +π/2. All right, it's really important to remember that domain and range for inverse trig. Next, I'm going to slide down so you can see the various definitions for inverse trig functions. Feel free to pause as needed to write down any rules you may have forgotten from pre-calculus. So we've got our inverse sine, cosine, and tangent. And then our definitions for cotangent, secant, and cosecant. So next, let's take a look at one example from pre-calculus to jog our memory. Let's find cosine of inverse sine 3/5. Let's recall we can write our inside stuff as theta equals inverse sine 3/5. And we can write that, which means sine theta equals 3/5. We can recall our 6 trig functions where our sine theta is equal to our y value over our r value. We can see our sine value is positive, so that means we must be by definition in quadrant 1. Drawing my triangle, I have my y value is 3, my r value is 5, and I'm missing my x value. Again, we must satisfy x squared plus y squared equals r squared. Plugging that in, we should get our x value is 4. So remember the 3, 4, 5 triangle. All right, now that I have this information, I can go ahead and find cosine of this triangle. Again, recall our formula for cosine is x over r, and so our final answer is 4/5. All right, now that we have reviewed inverse trig, we can take a look at the derivatives. To find the derivatives of our inverse trig functions, we can use a theorem that I talked about in my previous video. And so here I have just a quick example of finding the derivative of arcsine using the definition of derivatives for inverses. And I'll let you go ahead and pause the video and take a look at this if you would like. So doing the theorem each time can be a little lengthy. So we have our inverse trig derivatives as rules that you can take a look at. And so I have them all written down for inverse sine, cosine, tangent, cosecant, secant, cotangent as rules that you can memorize. And so again, I'm just going to scroll through these and you can pause the video as needed to jot down any of these rules. All right, let's take a look at one last example. Let's find the derivative of f of x is equal to arcsine x squared. Again, I wrote down the rule one more time. To take the derivative of arcsine u is equal to 1 over the square root of 1 minus u squared times du dx. And of course, we cannot forget the chain rule. So let's go ahead and take a look at finding the derivative of arcsine x squared. So we have the derivative is going to be equal to 1 over square root 1 minus x squared squared, watch out for all those squares, so be careful, times the derivative of what's inside, chain rule, so we got a power rule with x squared, which is just 2x. And there we go, there's our derivative. I suppose I can write this a little prettier with 2x in my numerator, and go ahead and simplify the x squared squared as x to the 4th. And there we go, we have found the derivative of arcsine x squared.